All right, guys, are there any questions on the homework? All right, so what we're going to be doing today is solving different type of equations. The first few that we'll solve will be rational equations, or really the first main one's going to be rational equations. We'll go through it and how we solve those. Then we'll move on to radicals, U substitution, and some fractional exponents. Now, solving rational equations, we've done these before. They're not that bad. When we look at them, one of the main things we need to do is make sure all the denominators are factored as far as possible. Because once we get them factored, we can multiply through to get rid of them. Now, if we look at these here, so the first one, 2x over x minus 4, is as factored as far as it can in the denominator. The x plus 2 is factored as far as it can go because we don't have any greatest common factors, and the degree is 1. So that's as simplified as those get. Now, the denominator of our third one here, x squared minus 2x minus 8, can be factored. Now, there's not a greatest common factor, so we can move on to our two sets of parentheses with 3 spaces. Since the third term is negative, our signs are going to be opposite. One's going to be positive, and one is negative. Luckily for us, we're just looking at the factors of x squared, which are just going to be x and x. And our factors of 8, I'll put up here, are 1 and 8 or 2 and 4. Now, most likely, it's going to be 2 and 4, and it's going to match up with the ones we already have. Since we have an x minus 4, x plus 2, so what we're hoping to work out is that this factors of x squared minus 2x minus 8 is going to be x plus 2 and x minus 4. If it is that, then it's going to work out a lot nicer. And if we did check for the middle term, x times negative 4 is negative 4x, plus 2x is equal to negative 2x, which is our middle term. Okay? Questions on this so far? Now, before we start actually solving it, we do have some restrictions. Essentially what x cannot be, because we cannot have a value of x that will make the denominator be 0. And if we look at this here, so x minus 4 and x minus 4, what value of x will make that 0, which is 4, because 4 minus 4 is 0. So if we get a solution where x is equal to 4, we know automatically it won't work because it would make one of the denominators 0. Well, with x plus 2 and x plus 2, that would be negative 2, because negative 2 plus 2 is 0. So 4 and negative 2, if either one of those come up as solutions, we can throw them out. They don't work. Questions on this so far about the restrictions or how we have this set up? Now, at this point here, it's going to be easiest if we can get rid of the denominators. Because if I multiply this x minus 2, or not x minus 2x over x minus 4 by x minus 4, it would cancel out with the denominator. It would simplify out, yes? Because the x minus 4 and x minus 4 here would cancel. So we're actually going to multiply the whole thing by x minus 4. And it actually over here on the right, this x minus 4 and this x minus 4 would cancel out. Are all the denominators gone? Well, no, the middle one has what? X plus 2. And if we multiplied it by x plus 2, those would cancel. But if we do it to 1, we've got to do it to all of them. And luckily for us, over here on the right, those will cancel as well. Questions on what we did there? So we're really just multiplying everything by the denominators to get them to cancel. And if we look at each individual term now, the first term, 2x, is going to be multiplied by x plus 2. Because that's what's left over, it didn't cancel out. Minus 3 times x minus 4 is equal to x squared plus 14. Now at this point here, most likely we're going to have a quadratic. We do need to multiply it out to make sure. because we can simplify. So we can multiply through. 2x times x is going to be 2x squared. 2x times 2 is going to be plus 4x. Negative 3 times x is going to be negative 3x. And negative 3 times negative 4 is going to be plus 12. It's going to equal x squared plus 14. Once we finish combining like terms over here, we'll have 2x squared plus x plus 12 is equal to x squared plus 14. Now at this point here, we do need to move everything to the same side. So we can subtract x squared from both sides. We can also subtract 14. If we do this here, 2x squared minus x squared is going to be x squared plus x. 12 minus 14 is negative 2. And at this point here, we just need to solve this quadratic from here, and we'd be done. Now again, there's many different ways to solve quadratics. On Monday, we went over several of these here. We did a few on Tuesday. We can solve it by factoring. We can solve it by completing the square. We can solve it by the quadratic formula. We can do any of these here. We could graph it. Any one of these would work. Now, if we factored, we do our 2 sets of parentheses with 3 spaces. Since the third term is negative, our signs are going to be opposite. The factors of x squared are x and x. And the factors of 2 are 1 and 2. And which one would be positive? The 2, because if we check this here, x times negative 1 would be negative x. Positive 2 times positive x would be plus 2x, which would give us a positive x, which we wanted. So our 2 solutions are x plus 2 and x minus 1. Because of the zero product property, any 2 things multiplied together to equal 0, one of them must be 0. So we can set both of them equal to 0 and solve. So x is equal to negative 2, or x is equal to 1. So here are the 2 solutions we get. However, that negative 2 should look familiar. We've already had it show up once, yes? It was one of our restrictions. So x equals negative 2 does not work. Because if x is negative 2, in the original problem where we started off, it would make one of the denominators, or more than one of the denominators, be 0. So it does not work. Questions on any of this here? So hopefully you remember this sum from Algebra 2. We've done these before. They're not bad. Once we figure out what the denominators are and what we need to multiply everything by to get the denominator to simplify out, we're just going back to quadratics. Any other questions on this here? Okay. Application involving uniform motion. Now, with any of these here, we're talking about rate times time is equal to distance. And we're going to be solving for one of these 3. We're either going to be solving for distance, time, or rate. And if we look at this problem, Trent takes his boat 6 miles downstream with a current of 1.5 miles per hour. The return trip against the current takes 1 hour longer. Find the speed of the boat in still water in the absence of current. So really, we're just trying to find out how fast the boat was traveling. Trying to find speed. Now, this seems like a lot to put together, so we're going to have a chart to put all this together with. Now, we're talking about rate times time is equal to distance. Rate times time equals distance. And there's going to be 2 directions we're going. One is going to be with the current, so I normally draw an arrow up, or against the current, and with the current. If we're going up the stream, we're going against the current. If we're going down the stream, we're going with the current. And we have our speed of the boat. And we also have the current. So we have this set up so we can organize all of our data and put it in. Now we do have one little spot missing up in the top corner, since it's word problems. Put a little smiley face. Make us happy for a little bit before we get started with this here. Now, let's look at what they gave us. Trent takes his boat 6 miles downstream. So he's going 6 miles downstream. How far upstream is he going to go? Because he went downstream and then came right back up, yes? So if he's going 6 miles downstream, how far is he going back upstream? 6 miles. So we know that. With a current of 1.5 miles per hour. Okay, so we know the current. We fill that in. The return trip against the current takes 1 hour longer. Find the speed. Okay. So we know whatever time it took to go downstream is going to be 1 hour longer than upstream, yes? Okay. We know the speed of the boat is what? X. Now, rate. So we will have an X, because the speed of the boat will be part of the rate, yes? Now, if we're going with the current, is it helping us to go faster or slower? Faster. So we would say X plus 1.5. And if we're going against the current, we're going slower. It's resisting our speed. So, time. Did they tell us anything really about time except for we're traveling 1 hour longer? No. But what do we know? Rate times time equals distance, yes? So time is equal to what? Distance divided by rate. Because rate times time is distance, we can divide both sides by r. Because time, rate divided by, or rate times time divided by rate. If I divide this by r, those cancel, leaving us time by itself. So time is equal to distance divided by rate. So our time here would be what? The distance 6 over x minus 1.5. Here we'd have 6 over x minus plus 1.5 would be our time if they were equal. Because if they were straight equal, we'd be good here. But what's the one last piece of information they gave us? The return trip takes 1 hour longer, yes? So we just have to add 1. Add another hour. Because all of this is already in miles per hour. Questions on any of this so far? Set these two equal. Because once we get this set up, something's going to be equal. And the one that's going to be equal is going to be the one that we've kind of calculated out. So if they didn't tell us the distance, but they told them they were going to be the same, they're going to give us a time kind of going up and down the river, or one of them will be multiplying together, or we'll be solving for one of them. Now at this point here, we can do the exact same thing we did on the last one. Because if I multiply the 1 on the right side by x plus 1.5, we know that these two will cancel out. But we still have one other. We have the x minus 1.5. Well, over here, those two will cancel each other out. And with that, all the denominators will be gone, leaving us with 6 times x plus 1.5. plus x plus 1.5 times x minus 1.5 is equal to 6 times x minus 1.5. And now we can start solving from here. So for the first one, we can multiply through by 6, which will give us 6x plus 9. And we can just do that in a calculator. We can say 6 times 1.5. Clear. 6 times 1.5 is 9. Plus, here, we're going to distribute out. X times x will be x squared. Almost. Okay. Plus, so x squared. X times negative 1.5 will be negative 1.5x. 1.5 times x is going to be plus 1.5x. Minus 1.5 times 1.5, I think is 2.25. Is equal to 6 times x is going to be 6x. 6 times negative 1.5 is negative 9. We can combine like terms, so we'll have x squared. Negative 1.5x and 0.15x will cancel out, leaving the only x term over here, 6x. And 9 minus 2.25, so it's going to be positive because 9 is definitely bigger than 2 1/4. Now I know I will have 0.75, yes? Because 0.75 plus 2.25 is 3. 9 minus 3 is 6. Is equal to 6x minus 9. Okay. Now we need to start moving things, yes? Now I would say move everything to the one side, but what do we know about 6x and 6x? They're both positive, yes? So if I subtract 6x from both sides, what happens to our middle term? It goes away, yes? If we don't have a middle term, what method can we solve quadratics by? The square root method, yes? So here is a case, these cancel, I don't have to add the 9. Because if it's going to be the square root method, we need x squared by itself, yes? So instead of adding 9 to both sides, we can just subtract 6.5, and this is going to be, something's off. This is off. Let's see here. Turn against the current. Takes 1 hour longer. Yep. Yep. Is the math off? Okay. I don't like this. Because that's negative 15.75. Why does that not work? It's a negative, because we can't take the square root of both sides, because square root of negative would be I. No solution. Yeah. X. Really? same as one sine, solved in the 1 hour longer. Because if they would be the same, then they would be equal to each other. 1 hour longer. Like this. Because if it's an hour longer, for them to be the same, we'd actually have to subtract 1. It's one sign change here. Now, for the most part, this isn't going to change anything. I'm going to erase this whole thing here. You don't have to. I'm just wanting to re-show you this back out. Because what we would get here is still the x squared minus 1.5x plus 1.5x minus 2.25. Now, when we distribute the negative, well, these will still cancel. But what we're going to get out of here is negative x squared plus 2.25. Now, the 6x and 6x are still going to cancel. Except that's not going to be 6.75. Since it's plus 2, this is now going to be 11 0.25. Still is going to give us a negative. I'm going to do it how they said. Okay. I hate this. Here. Keyboard. Because there's something slightly off with these. Pull this back up. Throw those away. Now, yeah, if we could do that, that'd be so nice. Now, here, I've got extra paper here. Grab a few more sheets here. You're welcome. Welcome. Really, the issue that we're having is, well, that I had is the use of that 1 mile or 1 hour longer. Because if they told us it was the same time going up and down the river, we could just set these equal and we'd be good. So if we subtracted them and they were the same, it should give us equal to 0. But since one is 1 hour longer than the other, and if we subtract the shorter amount of time from the longer amount of time, it should give us 1. Which I don't see how that's any different. It's because if we add it to both sides, we'd have really the setup like this. Or if we add, because if we add 1 hour to going down the stream, it'll be the same amount of time as going up. Or really, if we subtracted from going up, we should have the same thing. Okay. Yeah, I'm going to keep going with this. I will backtrack and see. The math was going to work. I just stopped too soon. Now, we'll do the exact same thing. X minus 1.5, x plus 1.5. X minus 1.5 times x plus 1.5. Here, the x minus 1.5 and x minus 1.5 will cancel. Here, x plus 1.5 and x plus 1.5 will cancel, leaving us with 6 times x plus 1.5 minus 6 times x minus 1.5 is equal to, here we have x minus 1.5 times x plus 1.5, and we get this here. Now again, we're going to distribute. So I have 6x plus 9 minus 6x minus 9 is equal to x squared minus 1.5x plus 1.5x minus 2.25. That whole side becomes 0. 6x minus 6x is 0. 9 minus 9 is 0. Is equal to x squared. These two cancel out, minus 2.25. Now at this point here, we can add 2.25 to both sides. We will get x squared by itself. And we get this here, x squared is equal to 2.25. And last but not least, we need to square root both sides. Oh, never mind. This really should be a Monday. I think this is the most mistakes I've made in a single lesson, isn't it? Yeah. Square root both sides. X is equal to. Definitely plugging this in a calculator. Is 4.5 miles per hour. Now we normally would add the plus or minus, but we know that x is equal to negative 4.5 is not an accurate speed. Questions on this here? After I've confused you all probably so bad with this. Now, give you a second to do this. Okay. I'm going to go back a little bit because with changing that from to a negative, okay, thank you. This here would have actually worked if I would have actually taken the time to go all the way through with this here. Because we have 6x squared minus 2.5, 6x minus 9. We have this here. X minus 2.25 from 0.25, and this would have been negative x squared. We subtract it, we don't get this. That's not 6.75 anymore, neither is this. But we're going to subtract 11.25. 9 plus 11 is, yes. But the x squared is not positive anymore, it is negative. And then I think we got 5.4, 4.5. We still get the same answer. I quit out of it because I still was seeing the negative. I forgot about this over here. All right. So on a whole, again, for me, and as I've said before, it's one sign change will make all the difference. And really, that's all it was. That one there needed to be negative, not positive. Now we're not going to, I'm going to do another one. They have two. I intentionally put two in here. Not because I knew I was going to mess that one up. But, so we can see another one of these. Upstream, downstream, current, rate. And again, when I see most of these here, this is how I set them up to go. Now, we didn't cover these in Algebra 2, but most of the time if we did, we would deal with more something being the same or something being different. Or mainly something being the same. Either you're going to be traveling at the same rate, same time, same distance. One of these here, so we'd set them equal to each other and solve. A fishing boat can travel 60 kilometers with a 2.5 kilometer per hour current. So the current is told to us, 2.5 kilometers per hour. In 2 hours less time than it can travel 60 kilometers against the current. Determine the speed of the fishing boat in still water. So rate is x, because they didn't tell us the rate again. So we're still finding rate similar to the last one. So how far are we traveling up and down the river? 60 kilometers. Traveling the same amount of time. Now, going against the current, we're going to have x minus 2.5. With the current, we're going to have x plus 2.5. And just like before, so rate times time is equal to distance. If we divide both sides by the rate, we get the time, which is distance divided by rate. So for us here, the distance is 60, and our rate is x minus 2.5. Now, which one takes longer? Well, it's going to be with the current, yes? Because it told us how much longer is it going to take. 2 hours less. So if we take our 60 over x minus 2.5 and subtract from it 60 over x plus 2.5. Because we took the longer time and subtracted the shorter time from it. If, so this should equal what? 2. Because the amount of time that is difference between the two. Longer minus shorter. Against the current minus with the current. Yes? If we know that it takes t hours with the current, how long is it going to take against the current? Well, t plus 2. Because if it took 1 hour to go down, it's going to take 3 hours to go up. So if we take the longer minus the shorter, we should get 2. Now at this point here, we're going to multiply everything by both denominators. X minus 2.5 and x minus 2.5 cancel. X plus 2.5 and x plus 2.5 cancel. Which leaves us with 60 times x plus 2.5 minus 60 times x minus 2.5 is equal to 2 times x minus 2.5 times x plus 2.5. Now at this point here, we can distribute. 60 times x is going to be 60x. Plus 60 times 2.5 should be 150. Is indeed 150. Minus 60, negative 60 times x is going to be negative 60x. Negative 60 times negative 2.5. Negative and negative make a plus. 150 is equal to 2 parentheses. It's going to be better to distribute these first instead of trying to multiply them together and the 2 all at the same time. X times x is going to be x squared plus 2.5x minus 2.5x minus, so 0.25 squared is 6.25. Questions on this so far? Now over here, the 2.5x and negative 2.5x will cancel. On the other side here, we do have some things that'll simplify. The negative 60x and 60x will cancel. And 150 plus 150 is 300. Is equal to 2 times x squared minus 6.25. At this point here, we can distribute the 2, which will give us 2x squared minus 6.5 times 2 is, or 6.25 times 2 is 12.5. Now, since we don't have a middle term, we can move everything to the other side. So I'll have 300 plus 12.5 is 312.5 is equal to 2x squared. At this point here, we can divide both sides by 2, telling us that x squared is equal to 1, 5, 6.25, 312.5 divided by 2 is 156.25. And last but not least, what do we need to do? Root both sides. Now we don't need the plus or minus because we're talking about speed of a boat and it needs to be positive, so 12.5 Does that make a little more sense? Hopefully it's not as confusing as the first time we did it. Yes. Okay. 12.5. So with the current, so rate's equal to 12.5. So with current, so we'd add 2.5 to it. 0, they'd be traveling 15 kilometers per hour. Against current, we'd subtract 2.5 from it, we'd be going 10.0 kilometers per hour. Does that kind of make sense with that there? Now, when we're getting our answer, we should know that the answer is not correct if we find the rate of the boat is going equal to or less than 2.5. Why would we say that? Because what's the rate of the current? 2.5, yes? If I'm going less than that or equal to that, am I going to be able to go up that river at all? No. So that's another thing we can check to make sure, because if it's not equal, if it's not bigger than the current, it's not going to be any good. I mean, even if we're 1 mile an hour faster than the current, you're probably going to tear the motor up just trying to get up that river. You need to be decently faster than the current. Questions on this here? Hopefully that second time through made this make a little more sense. And that's really it. Now, some of these here, they'll do different ones. They will give us, say, the distance. They tell us that it traveled the same. And some of this here, and they give us the time going up and down the river. We don't know the speed, but we know they're the same. We'll do almost the same thing, but our distance is just going to be taking these two, multiplying them together and setting them equal. Because for most Algebra 2 classes, that's what we'll do. We won't make the time different. But we'll pick up here tomorrow. 1.7 we'll cover next week. Or we might be able to get it in tomorrow. We'll see. 1.7 is very easy on a whole. But we'll stop.